Hello everyone, this is Vamsi Krishna, Assistant Professor in the Department of EAE, VNR VJEC. I am here to discuss about few topics on process control automation. I will be using the software TIA portal and I will be covering the topics timers and counters. And later on in the extended series, we will be discussing few examples on the same. Okay, first I will be telling you about the TIA portal. Now, if you look at I have installed the TIA portal software in this PC. This is the TIA portal software. First, I have double clicked on it. I am going through the initial process steps. So, please and try to correlate it carefully. First, we need to select a new project. Here we can give any name for the project. I am going with the default name. I am creating the new project. Then we will be going through the first steps of the TIA portal software. First, we need to configure the device. We need to configure what type of PLC you are using, the series, the type, the number of inputs, etc. So first I am selecting the configure a PLC and then I am adding the new device. Okay, the PLC that we are using in our lab is of Simatic S7 1200 series. So I am selecting the Simatic S7 1200 series PLC. In our lab we are having CPU 1211 and 1215 type DC. I am going with the CPU 1211 type DC software. By looking at the PLC, you can identify the part number. The part number is usually present on the right hand side of the PLC. So I have taken the CPU part number and then I am adding it. Okay, now the next step that we need to do is to assign a proper IP address to the PLC. Okay, the care has to be taken such that the IP address of your PEC should not be same with the IP address of the PLC, otherwise the communication cannot take place. So the first thing that we need to do is to assign the IP address. So for assigning the IP address, you can right click on the PLC over here and select the properties, or you can directly select the click on the IP internet port that you can see over here. Okay, I have clicked on the Profinet interface. I have clicked on the Profinet interface and I am assigning the IP address. Okay, you can assign the IP address that you are using over here and then save the project. Okay, in the industry we usually take the IP address of the PLC that you are programming and then assign the IP address. Okay, now for programming we need to go to the program blocks that is present on the left hand side. Next I am going to the main OB1 through which you can give the ladder logic programming. So I have taken the basic interface of the ladder logic programming. First I will start with the timers and then we will go to the counters and other things. Okay, so first there are three major types of timers that are present: on timer, off timer and retentive timer. Okay, first I will start with the on timer. Everyone, please make it a point to remember that you can give the name for the timer as per your choice. I am using the default name and you need to specify the timer should be a manual or automatic. Automatic is the most commonly most preferred option. Okay, so select it as automatic. Okay, in one rung I have taken the off timer. I have taken the off timer. The up one is the on timer, and then the other one is the retentive timer. For these three type of timers, I am assigning the inputs and outputs. So the normally open and the normally closed are the type of inputs that we generally use, and the this is the output that we generally give. So I am assigning output to all the three timers. I am assigning the output to all the three timers, and I am assigning the inputs also. Okay, this is the input. This is the input for the off timer, and this is the input for the retentive timer. Now, if you can look carefully for all the three timers, for the on timer you have the input, for the off timer you have the input, and for the retentive timer there are two inputs, input and the reset. Okay, for the reset, so I am taking the input. Okay, please remember that PT indicates the preset time that you are going to give, and ET indicates the elapsed time. Okay, and the units of the preset time here are usually in milliseconds. So if you want a preset time of 5 seconds, you need to give 5000 as the input over here. Okay, I have given a preset time of 10 seconds over here, which is clearly visible. Here for the off timer, I am giving a preset time of 12,000 seconds, and for the retentive timer I am giving a preset time of 30 seconds. Okay, now I will be assigning input addresses to the inputs as well as the outputs. For the programming purposes, I am using memory locations as the addresses. M0 M0.0, M1.0 for the output address, M0.0 for, sorry, 0.1 for the off timer input, M1.1 for the output, M0.2, M0.3 for the input and reset input address, and for the output I am using M1.2. Okay, now I will show how to properly assign tags for this one. Okay, here we are getting the default tags. I am renaming it. Okay, here when we click on this tag option, you will be getting the rename tag option. So first I am assigning it as on timer input. This one I am assigning it as off timer input, and here I am assigning retentive timer input, and this is the retentive timer reset switch. Okay, I am assigning the names for the outputs also. Retentive timer output, off timer output. The previous one is on timer output, this is off timer output, and this one is retentive timer output. Okay, these are the three addresses. Once you are done with the programming, save your project, and then we need to go to the simulation. Before going to the simulation, I will tell the working of all these three timers, and then I will demonstrate the working with the help of the simulation toolkit. Okay, the logic for these three timers is very much simple. So this is the input signal that you are giving. When the input is high, the output will be 0 till 10 seconds is elapsed. After 10 seconds, the output will become high. It is when you are taking the on timer. Before the 10 seconds, if the input is made low, the output will be low as in the previous state. If you consider the off timer, when the input is made high, the output will be high at the same time. And the instant you make your input low, till the preset time is elapsed, the output will be in the high state. After the preset time is completed, the off timer will be in the off state. If you consider the two previous examples that we have taken, on timer and off timer, whenever the input is made low, the system, the elapsed time is going to 0, that is in the default state. It is resetting itself. But if you consider the retentive timer, the reset is has to be done manually. Uh, okay, here for example I have taken 30 seconds as the preset time. Let us assume that you have given a high input to the retentive timer over here for 10 seconds. Then for 10 seconds the elapsed time will be 10 seconds, and if you give a 0 signal for 5 seconds, the elapsed time will remain at the 10 seconds only, and whenever you are making the input high, from that particular point of time only the counting will be starting. And once this preset time is completed, the output will be high even when the input is low. The system will be reset when you are giving a input signal to the reset. When the reset pin is made high, the output will be made 0, and you can work on it. Okay, now I'll show you the demonstration, and then we will be getting a better idea on the on timer, off timer and retentive timer. Okay, first I will be doing the simulation. Okay, for the simulation we will be using this start simulation option. Okay, in the start simulation option you need to press the start search, and then select the PLC that you want to use, and then select load option. Okay, load, and then start module. Okay, we are done with the loading. Now we need to use the monitoring option for doing the simulation work. I have started the monitoring option. Now you can observe that the green lights are glowing over here, indicating that we are doing the simulation on monitoring it. Okay, now first I am making the input as high. When the input is made high, you can see the elapsed time over here in the on the timer, on timer. Okay, once the 10 seconds is completed, you can observe that the output is high. When I make the input low, the output will be low instantaneously. The case that we have seen is the case when the input is high for more than 10 seconds. Now I am showing you again I have made the input as high, and before the 10 seconds if I make the input as low, the output will be in the low state only. Okay, now let us consider the off timer. Okay, when you make the input as high, the output will be high. I am making the input as high, the output is high. Now, when I make the input low for 12 seconds, the output will be high, and then the system will, and then the output will be low. I am making the input low. When I make the input is low, then the timer gets activated, and once this 12 seconds is completed, then the output of your off timer will be low. I think the demonstration was enough for understanding. Now, let us look at the retentive timer. The preset time that we are given is 30 seconds. I have made the input as high. When I have made the input as high, the timer of elapsed time has started counting. So here you can clearly observe the time that is going on over here. Once I make this elapsed time as 0, you can observe that the elapsed time has stopped at the previous value at the instant this input is made high. Okay, our preset time is 30 seconds. This value is less than the 30 seconds, so our output is low. Once I make the input high again, it will start the counting of the time from the previous instant where we have stopped, and the counting continues. Okay, you can observe that the counting is increasing, and once the counting crosses the 30 seconds, the output is made high. Now I have made the input low for your retentive timer. When the output is made low for the retentive timer also, you can observe that the output is in the high state. When you reset your switch over here, then the output will be turned low, and you need to make your output reset low again for this system to work properly. So that is about the retentive timer. Okay, I hope you have understood the basics of the on timer, off timer, and retentive timer. In the coming next videos, we will be discussing few example cases of on timer, off timer, and retentive timer by few applications. That's it for today's video. Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.